This is going to be a video on lesson 29. I'm Mr. Doyle. This is an exploratory challenge, so honestly, I would encourage you to go through this yourself if you want, because it is a good thing to try. It's meant to be done on your own. But if you're not super confident with solving for percents and things like that, I did want to do this just so you could have something to follow along with if you wanted to. If you haven't already, do A on your own, because that is making a prediction. So I'm not going to make a prediction for you because I already know the answer to this. And you're making a prediction about the claim that to find 10% of a number, all you need to do is move the decimal to the left once. So what that means is if you had like a number, let's say 723.58 and 58 hundredths. To find 10% of this number, what it's saying is move the decimal place from here to the left once. So put it here. So it would look like that. And that would be 10% of the original number. That's what it's saying. So you can make a prediction, and then I'm going to go through and do these. So determine 10% of 300. I'm going to solve all of these using proportions because that is my preferred method to show you how to do these things. So I'm going to have, these are all, since they're all 10%, they're all going to be 10 over 100. Right? So this is going to be 10 over 100. I'll try and do this kind of quickly. So it might be a little messy, but it's just for following along. Equals 10 over 100. I'm just setting all these up because all these say find 10%, find 10%, determine 10%, same thing. Okay. So determine 10% of 300. Now, one trick I will let you know is whenever you have these finding percents type of sentences and it says of is a dead giveaway that the thing that comes after it is the whole number. So when it says of 300, 300 is the whole. Of 80, 80 is the whole. So we're trying to find 10% of 300. So we're going to put 300 down here. I think that's 300. I can't see it anymore. Let me erase that. Yeah, 300. This one we're going to finding 10% of 80. This one we're finding 10% of 5. This one we're finding 10% of 64. And again, I'm putting the 64 down on the bottom. Remember, because one fraction represents 10%, 10 over 100 is 10%. The other fraction is going to be the part over the whole. And I'm trying to find the part. I'm trying to find 10%. So the number on the top would be equal to 10% of 300, because 300 is 100%, or the whole. So, with this one, I can think, okay, how do I go from, now that these are all set up, I can kind of look for patterns, either from fraction to fraction, or from the numerator to the denominator. So here, this one I can see really easy. The 100 times 3 is 300, so I can do 10 times 3, and it's 30. So 10% of 300 is 30. This one, there's no pattern back and forth this way necessarily, but this is going from 100 to 10 is divided by 10. 80 divided by 10 is 8. So 10% of 80 is 8. 10% of 64, this one again, 64 doesn't go in super evenly, so I could divide this by 10. 64 divided by 10 is 6.4. 6.4. Hopefully you're already seeing that this is true. And 10% of 5, you could, here's another pattern I see. I could divide this by 20. 10 divided by 20 is equal to 5. So 10 divided by 20 would be 10 over 20, or that's 1/2. 0.5. Right, in decimal form since we're trying to prove decimals. So already you should really see that this is true. And so this, because look, 300, the decimal place is starting right here. That's actually a period on decimal, but you know, if you took 300 and the decimal place is here and you move it over, you get 30. You have 80, that's where the decimal place would be, right? We don't have the decimal place on these numbers necessarily because there's no decimal, but you move the decimal over and you'd have 8. 64, you'd have the decimal place, you move it over, you get 6.4. 5, you have the decimal place, you move it over 1, and it's 0.5, 0.5. So 10% of 48, right? You got 48. Think 48.0 if that helps. 48, 48, move it over. What do we have? 4.8. 6 in decimal form, you'd move the decimal over, so you'd have to have 0.6. 0.6 or 0.6, 6/10. All right, so Gary read 34 pages of a 340-page book. What percent did he read? You should see that he must have read 10%, because 34 is 10% of 340. So you have the decimal right here, move it over, 34. So he read 10%. Micah read 16 pages of his book. If this is 10% of the book, how many pages are in the book? Now this one is just the opposite, because it's saying that 16 books is equal to 10%. So this one is not finding 10%, this is 10%. So, well, how you get from a 10% to 100%, you multiply by 10. So this would be 160 books. All right, or think, here's the decimal place, and you're just going the opposite direction. You're moving it to the right ones. Moving it from here to here, 160 pages. You can write this, fill this in yourself, but the conclusion is true. And this is why it drives me nuts. Personal rant here. If you're ever, when you're an adult and you are at a restaurant, right, and you're trying to give people a good tip I would say is 20%, because that's what these people live on. Then, you got all these people with their fancy calculators and things figuring out tips. It's not rocket science. You take the bill, you move the decimal over, and that's 10%. And then you could double it or do whatever you want. It's very easy to do in your head. Exploratory challenge 2. If an item is already on sale and there's another discount taken off the new price, is this the same thing as taking the sum of 2 discounts off the original price? This is an awesome example of how companies do things to trick you. If you're not math savvy, make a prediction. Is this true or false? And what this means is, this is a good thing to explain. So let's say that you go to the store and you are buying a fancy TV, a giant 70-inch 5K TV. It's going to be the greatest thing ever. Okay, so what this thing is saying is, let's say this item is already on sale and there's another discount. So let's say you go and there's a tag on it and it says 20% off. It's like it's on sale for 20% off. Okay? And then let's say you have a coupon for like 10%. I have a 10% coupon for the TV. I wish that they gave out coupons for TVs. So, what they're saying is, if you were to go buy this TV that was 20% off and you took it to the counter and they said, oh, your price, 20% off is whatever it is. And then you're like, oh, and let me give you this 10% coupon. And then you give them the coupon, right? Is that equal to just the TV being 30% off, the 20 plus the 10? Is it the same as 30% off, or is it different? So make your prediction. And then we're going to go through this. Okay. So B says, Sam purchased 3 games for $140 after a discount of $30. What was the original price? This is super tricky right here. Let me just tell you why this is super tricky. This tricks people up all the time. Okay, because this says he purchased 3 games for $140, discount of 30%. So a lot of times what people will do to solve is they'll go, oh, 100, right? I've got my 30%. I spent this much money, and I'm trying to find the original price. So this is what I'm missing. Let me just go solve this now. But this is not right, because $140 represents what you paid. This is what you paid. And this was a discount. So these don't match up. This is how much you paid, but this is how much you saved. They should be both how much you saved or how much you paid. So what you have to do is, we don't know the original price. So we don't actually know how much we don't know how many dollars were discounted. But if you know that the discount is 30%, you know that you paid, if it was discounted 30%, that means we paid 70%. So if you ever have 1%, you can always figure out the other percent. So we don't need 30% here. We want 70%, because 70% is the percent that we paid, and $140 is the dollar amount that we paid. And we want the whole amount. Okay, so if I'm looking for multiplying, dividing patterns, I don't see one necessarily going from the numerators to the denominators, but right here I see one. And it is times 2. 70 times 2 in this direction. So 100 times 2 would be 200. So the original price was $200. Cool. There's that one. If Sam had used a 20% off coupon and opened a frequent shopper discount membership to save 10%, would the games still have totaled $140? Okay, so what we first need to do is find out what 20% is, because first you would use 20%, right? When you imagine you're doing this in real life. You would take these games to the counter. They cost $200. You take them to the counter, use a 20% off coupon. They deduct that cost. And then you're opening a shopper discount for 10%. And then they're going to take 10% off. So let's do that. First, we need to find what 20% of 200 is, which is very easy because we just learned how to find 10%. So let's find 10% of 200. 10%, right here. 10% of 200 equals 20, right? We just move the decimal place over, right? So if 10% is 20, that means that 20% is going to be $40, right? Because I'm just doubling this. 10 times 2 is 20. 20 times 2 is 40. So 20% is $40. So we have our, let's say that this is the coupon. Hold on a second, my headphones just died, so I'm going to switch the sound. So Okay, so the coupon, this is going to be after the 20% coupon. And so we would have $200 minus, this was the 20% coupon, right? $40. I'm going to subtract this. So $20 minus the $40 equals $160. So right now, it's $160, right? The game has now cost $160. Now we are going to open a frequent shopper discount membership and save 10%. But how much does the thing cost now? It does not cost $200 anymore. It costs $160. So now, with the, I'll say membership. With the membership, which is 10%. With the membership, we have the $160, right? Minus 10%, right? Because it's 10% discount. So that would be $160 minus, what is 10%? Oops. What is 10% as a dollar amount? Well, it's, remember, you move the decimal over. So it would be minus $16. And that equals $144. Aha! So this right here is, if you're missing the final thing, $144 would be what it costs. Oops. If you did a 20% off coupon and then a 10% savings, it would cost you $144. If you had one sale that was just a discount of 30%, you would pay $140. So what you should be taking away is that stacking coupons one on another is actually not as good of a deal. So lots of times companies will do this to you because they'll be like, oh, everything is 50% off the sale price. Well, it's really not 50% off because it's 50% off an already discounted cost. So they do that to trick you so you think that you're saving more money, but you actually are not. It is a way to get them to, for companies to get you to buy more stuff. So there you go. That is lesson 29.